All right, in today's lesson, we're going to solve systems of equations again. We've already used two methods. So first method for solving a system we did by graphing. And we saw it has its flaws because unless we can graph great, it's hard to find that solution. So we have to use technology at that point. Then yesterday, used method 2, which was substitution, which involved plugging one equation into the other one. And here's our third method, and that's elimination. Now, elimination, there's many ways to do it. You can do it with subtraction or addition. We're just going to work with addition because I think it makes things easier. The key thing is, though, when you're doing elimination, is that you've got to first make sure your equations are ready for it. And by ready, what I mean is make sure you have it in standard form. X term, then Y term, equal sign, number. Also called your constant. So our first equation is set up that way, so is our second one. X term, then Y term, then equals and constant. And in a perfect world like this one is, the equations are set up, so all you have to do is add them together and one of the variables will disappear. And we literally add the two equations just straight up and down. These are like terms. These are X terms and Y terms and constants. And so the like terms are all lined up. We just add straight up and down. And because it's 4x plus negative 4x, that is 0x, the x term will disappear when we add them. But 8y plus 2y is 10y's. 20 plus negative 30 is negative 10. Divide by 10. 10 divided by 10 is 1y equals negative 10 divided by 10 is negative 1. You just found out the y value of where these two lines intersect each other if you were to graph them. Now we have to find the x value. Remember, we're looking for an ordered pair, that intersection point. Now to find out your y or your x value, you just take that y, substitute it into either equation, because they both are going to go through the same x value. So I'm going to plug it into the first one, just because that's where my arrow points to. Plus 8 times, here comes that substitution. Let's make that dark. There we go, equals 20. And we just solve for x now. For x, 8 times negative 1 is negative 8. Let's add our 8 to solve for x here. Undo that addition first. So for x equals 28, and divide by 4, x equals 7. These two lines intersect or share a solution where x is 7 and y is negative 1. Now this is a beautiful example in terms of what we're trying to do. Elimination means add the two equations together to eliminate one of the variables. In this situation, because it was a 4x and a negative 4x, they automatically added up to 0. It will not always be that case. So let's look at one where that doesn't happen and how we can rig the system to make it happen. So here I've got my first equation. I'm going to color that one in red. So I can call it the red equation and my blue equation. If I were to add red plus blue right now, look what would happen. 8 plus negative 3, that'd be a 5x, and y plus y would be a 2y. Nothing would disappear. I would not eliminate a variable. One of the beautiful things we can do is always multiply both sides of an equation by the same thing, divide both sides by the same thing, add or subtract by the same thing. In this case, we're always going to use multiplication. Well, not always, but 99% of the time we can use multiplication to rig the problem so if I were to add them, something would disappear. In this case, if one of these was a negative y, I'd have negative y plus positive y would add up to 0. 1y minus y would equal 0. So I just need one of those y's to be negative. So let's take the red equation times negative 1. Now notice I put the entire equation in parentheses because you're going to have to multiply everybody by negative 1. It's a huge distributive problem, essentially. It's not, well, I'd probably get grief from other math teachers. You're taking both sides times negative 1. But that gives you negative 8x, negative 1 times 8. Negative 1 times y is negative y. And negative 1 times negative 16 is 16. So it's the same equation. I've just multiplied it by a negative 1 to make it look essentially different. The second equation I'm not going to do anything to. Negative 3x plus y equals negative 5. And I don't have to do anything to the other equation because now it is set up. So when I add the negative y and positive y, the y's will disappear. They add up to 0. Let's go ahead and add those two together. Negative 8 minus 3, negative 11x. The y and negative y give you 0 equals 16 minus 5, 11. Divide by negative 11, both sides. X is negative 1. Now when you go back to find the y value, you can use any equation that you have up here. I'm going to use the original 8x plus y equals negative 16. That's the one in red up here. X now I know is negative 1. And that's negative 8 plus y equals negative 16. Add 8. And y is negative 8. These two lines cross at negative 1, negative 8. Now our last example, similar, I'm going to have to fix it. Notice in this case that if I add straight up and down, nothing would be eliminated. Negative 4 plus 1y is negative 3y's, and 9 plus negative 3, that's 6y's. So nothing's going to disappear. I have a choice now. I can either get rid of the x's or the y's. Right? If I were to get rid of the x's, I'm going to have to fix this equation right here. I want this to be a positive 4 because then negative 4 and positive 4 would add up to 0. So let's fix it by taking it times a positive 4 because that will give me a plus 4x. Right there. Now I'm going to have to change everything else too because I got to multiply everybody by that. So here's the top equation. Let's put that in blue. Negative 4x plus 9y equals 9. Here's the bottom equation, distributing that 4. 4 times x, 4 times negative 3, and 4 times negative 6. And now we'll add those two equations together. Here's what I wanted to happen. Negative 4x plus 4x is 0 x's. X's have been eliminated. 9y take away 12y is negative 3y. And negative or positive 9 take away 24 is negative 15, I believe. Divide by that negative 3 and we'll have the y value of their intersection. Negative 15 divided by negative 3 is 5. Now when I go to find the x value, that x point of intersection, I again can plug it into any equation I want to. I'm going to use this x minus 3y equals negative 6, that original one. I'm using that because x is already by itself almost. Doesn't have a coefficient, so x minus 3 times my y value. Negative 3 times 5 is negative 15. Add my 15 to get the x alone. And it looks like x is 9. So these two cross at x is 9 and y is 5. And we're done. So the entire point is to multiply your equations by whatever number you need so that when you add the two equations, one of the variables gets eliminated. And that is it. All you have to do on the homework assignment are the odd problems. So it's 6 different problems. You will have questions, so make sure you look at it so you can come to class with those questions.